All right, so this is section 6.10, similar figures, and we're going to start solving mathematical problems using corresponding angles and sides of similar figures. And it's going to be a little bit of expansion on what we went over in 6.7, really. And, building a little bit on 6.8 and 6.9. But mainly 6.7 using proportionality as an understanding all that stuff. Okay, so we're gonna kind of start with just a basic refresher on proportionalities. We have this polygon, not necessarily a triangle, but it's a quadrilateral purple and a quadrilateral green here. And we have corresponding sides of these two quadrilateral, or I keep forgetting what I call them. But yeah, but they're corresponding sides. It's pretty obvious which ones are paired up. Like we have G and B, or line segment GB paired up with CP. GW is paired up with CN, and BE is paired up with PK, and then WE is kind of paired up with NK. So, and then our corresponding angles are, well, I guess I could mark these up a little bit, huh? Right size, a little bit better size here. Put this to like that. And I'll use purple. How about no, yellow's not good. How about this color here? All right, so we're similar size. I'm gonna say like that one is similar to this one here. Let's say this one is similar to this one here. Those two are similar. These two are similar. These two are similar. Those are similar line segments, right? That are kind of paired up, if you would, corresponding line segment pairs. And then our angles. Right? So these are proportional line segments. These line segments are share proportion. And then the angles are congruent. So that's angle, the first single dash angle. This angle, we'll call this a double dash angle. These measures are the same. So this is the angle.
You can't do that, bro. You can't walk.
That is a third angle.
It's a gun, bro. You gotta aim.
That is the third angle there. And then say that this is the fourth angle. Okay, so those are all four distinguished angles there. Okay. So yeah, that's the way we go with that one. All right. So how do we those are the corresponding angles and then the corresponding sides for each of these. So how do we set up our statements, right? So we'll say that I can just, there's no confusing these angles anyway with other vertices. I don't have other angles like line segments coming off of here, right? There's no way that these vertices are going to be confused with anything else. I could try to confuse you with like angle BGW, but I'm not going to try to do that, right? So I'm going to say that angle G is congruent to angle C. I'm going to say that angle N is congruent to angle W is congruent to angle N. This one and this one. Angle E is congruent to K. Angle E is congruent to angle K. B is congruent to angle P. Angle B is congruent to angle P. Right, so those means that, remember that congruence means the measures are equal. Measures are equal, right, when you have similar images or similar polygons. Okay, but the line segments are obviously not the same, right? I'll just prove it real quick. If I take this guy and move it over here, see that it's same angle. So, anyway, so what is how are they similar? What is the similarity? If I were to set up a proportionality, if you would, what would some corresponding side and proportionality statements be for these here, right? So just for a second. Okay, so the other one, so let's start. We'll have our purple triangle, also our big triangle, our small triangle, our green triangle. So a couple ways we can set up proportionalities, right? We can go, we'll say we have our small triangle of a small triangle base length, we'll call that the base length, over our big triangle base length, right? So that's our, we'll say that's P, oh, so that's going to be P, K, over BE, over BE. That is one set of proportionalities, right? And if I were going to set another set of proportionalities to that, right, and I would have to pick like another line segment on the small triangle and make it set to the same corresponding line segment on the big triangle. So it would have to be like KN to like GW or WG. Because that's how I set it up to begin with. Right. Say I did CN over GW, right? GW. Right? It's like the inverse of the first one. Over GW, it would be the inverse. It would be the inverse of what I had before, right? It would be the inverse. It would be B, CN over WG or GW. Hold on a second, pause this. See what these things tell me. I would just flip this around too. It would be CN. Oh, I haven't used CN yet, have I? Let's say I had CN over WG, right? And I'd have to have, say I had a CP. Whoops, green. It would have to be like CP over like BG or GB. Over GB. Right. Now say I had like so this is green on top, purple on the bottom, green on top, purple on the bottom. Say I switched it up a little bit. Okay, let's say I had GW, right? GW equals CN. Right? This is a big one on top, little one on top, right? I would have to then still keep a proportionality, right? That's to be black. But that would have to be then the same type of length, right? So we'll say that this is then the this would have to be then the say BE. This is the purple one. We'll say BE, or the same polygon, BE purple, and the same length PK. Right, so you see the pattern, right? So it's either purple on the bottom and both purples on the bottom and both greens on top, both greens on the bottom, both greens on top, both greens on the bottom, both purples on the bottom, or on one side or the other. Okay, well, that's how the proportionalities work. And if you ever needed to solve for one of these, all you have to do is cross multiply, and you'll be able to solve for either one of those. Okay, so that pretty much sums it up. Let's see if I missed any of the scenarios. And VP. Nope, I don't think I missed any scenarios for that. Okay, so moving on to an example with numbers. So here is an example with some numbers. So it might give you an example like this, and it might give you an example with some words, and then with some numbers in the words, and then you fill out the numbers with the words. So this thing gives me two angles over here, then one angle over here that's different than those two angles, right? But if I look at this, do I actually have three different angles, or do I have that are like unrelated? Got kids playing in the background, sorry. 82 plus 59 is 141. If I subtract 180 from that, right, my leftover angle is 39 degrees, right? So that means that this angle is 39 degrees. 39 degrees. Okay, so that's probably a pretty good indicator that this one here and this one here are going to be 82 and 59 degrees if I can establish that this one and this one have the same proportionality of this one and this one, right? This one might not really help me, right? Or maybe it will if I can establish that one is also proportional, right? Because then I could do it by side, 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 or I could do it by side, angle, side, or I could do it by, or I could do by angle, angle, right? But I really don't have a way to establish these angles, right? I do know that these angles are the same, right? So my two options are angle, side, angle. Let me pause this for a second. All right, where was I? Yeah, so it's either angle, oh no, sorry, not angle, side, angle. It's either side, that's wrong. Either side, angle, side, right? Because there's no angle, side, angle when talking similarity. It's either side, angle, side, or it's going to be side, 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 side. All right, so let's do these two. All right, so if these two are congruent or similar, we would do like 22. Well, first we got to figure out which sides would be like the same. All right, so V and K, like this guy right here, this blank 22 is like the long one. So it would match up with A and H, which is like the long one, right? So, because that's the long one there. Right, so V and K, we go with, I should make these colorful, huh? So VK, we do it in the middle. That's a VK over AH should equal MV over RH because those are the like the similar sides, right? Opposed similar sides. If that's true, and the proportions are the same, right? Because this would be proportionally the same. Then these angles here are the same measure. Then these would be similar by side, angle, side. We could also be like, hey, if KM, if KM divided by RA also equals the stuff down here, equals that stuff down there, equals that stuff, then you could say they're similar by side, side, side as well. So if those numbers are all true. Right, so we can do some math real quick. Wonder if this thing has a fraction to decimal thing on here. I don't know if it does or not. Settings. Oh, that's not what. All right, so we'll just go with see what comes up. All right, so my VK is 22 divided by 17.6 divided by 17.6. This is like 1.25. 1.25. That's 1 1/4. That's a nice convenient number. All right. Clear that guy. And then we're going to do 19 divided by 15.2 equals 1.25. 25. All right, and just for the fun of it, we'll do the top one as well. So it's going to be 14 divided by 11.2, and lo and behold, 1.25. So we know we have more than enough to say that these two are similar. So we can say by side, angle, side, because these two are similar. And these two are similar, and they have to have the same proportion by 1.25 of similarity as these ones, right? They're all similarity exists, right? And then we know the angle is the same in between, right? That they're similar, but we also know that all these three sides are similar. So by side similarity, we know that's true as well. So more than enough information to know that those are all, these two triangles are similar triangles. All right. Moving on to the last one. Slide bar. And then slide all the way over. All right, here is a couple polygons here. I only know two of the angles, and I only know three of the sides here. Limited information. So what can I find out from this information here? Oh, if I think about all this, I would remember that the internal angles of a quadrilateral, like a square or a rectangle or anything with four angles, if I add them up, they're gonna equal 360 degrees. Right, so if I had 59, let's see, 59 plus 126 plus 74 plus 101, and all those equal 70 degrees. So that means that these angles in here that I'm missing are also these angles in here that I'm missing. So it looks like that this G angle here, right, this angle here is this angle here. And this P angle here is this angle here. So it looks like it's maybe rotated 180 degrees, maybe, and then kind of move down. So this would be, oh, let's see, this would be about a 59-degree angle. This would be our 126, and that's acute and obtuse, so that makes sense. And then that would make this our 101, and that would make this our 74. Okay, now I don't know if that helps us at all, but we'll label it just to be sure. Okay, now we got to figure out which kind of ones are lined up with them. I'm gonna do this. Oops. Maybe I won't do that. Maybe I'll just line it up like this. So G goes with B. That's G. Right, and then P is gonna be right this one with P. I guess it does help to line up the vertices. And D is gonna go with M. Y go with S. So that's gonna help me kind of match up my line segments. So which ones do I know? I know PG. So PG 6. DY 5.5. Okay. So, if I'm told, let's see, what else am I told up here? We can give it is 5.5, given 1, 2, 3 density values. Pause this and think on it for a second. Okay, so it's presuming that these are similar, right? Find the rest of the measures. All right, so this is a little bit backwards. So it's kind of like a scale factor thing, a little bit. So what is the proportion? Well, the only real proportion I'm given is right here. Is right here. Is this one. Is this one. The only real proportion I'm given right here is that one. That means that this, the red triangle, all the proportions are twice as big as the blue one. So I really don't need to do very much math here, right? So all the blue ones are half as much. All right, so PD is going to be half as much as that one. So this one's going to be 5. This one, we know those up here, right? So this one is going to be not 5.5, it's going to be double, it's going to be 11, right? 5.5 times 2 is 11. This one is going to be half as much as that, so that one will be 3. All right, so that's not too hard. I can do all that in my head because 12 divided by 6 was 2. All right, so each one of these was going to be, since this one was half as much, it's going to be half of its, it's a partnered side, if you would, right? This one would be doubled its partnered side, which is that one. So that's pretty easy there to figure out the rest of the stuff. So there you go. Hope that worked out for you. You guys have a great rest of the day.